Hey students, today we are doing the major paper 2024 of paper 4 variant 2. We have done the first 3 questions which you can find in the previous video. Now we are doing question number 4, 5 and 6 in this video. Let's start. Question number 4. A carboxylic acid reacts with an alcohol to produce an ester and water. Under certain conditions, this reaction can be reversed. So an ester reacts with water to produce a carboxylic acid and alcohol Y. The reaction reaches an equilibrium. The forward reaction is endothermic. So as you can see in this reaction, this is ester CH3, CH2, COO, CH3. This is a formula of an ester. It reacts with water to form X and Y. Now, X is a carboxylic acid and Y is an alcohol. The question is, deduce the empirical formula of this ester. Now we know that the empirical formula shows us the simplest whole number ratio between the atoms. So to find the empirical formula, first we'll write the molecular formula of this ester, which is 1, 2, 3, 4, 4 carbon, hydrogen 1, 2, 3, 4, 5, 6, 7, 8, 8 hydrogen, and there are 2 oxygen atoms. Now we can simplify it from the table of 2, and the empirical formula comes out to be C2H4O. Name the ester. We have to name this ester from the carboxylic acid and the alcohol which we are using. Now, to name the acid, we will see that what is the carboxylic part and what is the alcohol part. We'll split the ester from here. Just a quick tip, to name the ester, to find out the name, we will split the ester from COO and the other alkyl group, COO. So the COO, let's see how many carbons are there. There are 3 carbons, 1, 2, and 3. So this comes out to be propanoate, 3 carbon, propanoate, and the 1 carbon alcohol, which will be methyl from methanol. So it will be methyl propanoate. Name the carboxylic acid and draw its displayed formula. The carboxylic acid will be propanoic acid, and its displayed formula will be CH3, CH2, C double bond O, OH. This is the displayed formula of propanoic acid, 3 carbon with carboxylic group attached on the last carbon. Name alcohol Y and give its structural formula. The alcohol will be methanol, and its structural formula will be CH3OH, because it's just 1 carbon. Next question is complete the table to show the effect, if any, for each change of the condition. Now, when we change the conditions, we know that if a system is reversible and it is in equilibrium, then whatever change we do, the system will act as to oppose the change. According to Le-Chatelier's principle, it will always do the opposite of whatever change is done. So this reaction is in equilibrium, and we are making certain changes. So let's see where will the system shift and what happens to the concentration of carboxylic acid. If the temperature is decreased, then what will happen? If the temperature is decreased, then system will move towards the exothermic side. Which side is exothermic here? They said that the forward reaction is endothermic, which makes the backward side exothermic. So the system will move backwards and the concentration of the acid decreases. So we'll write here that the concentration of acid decreases. For the next one, the concentration of ester is decreased. So if we decrease the concentration of the ester, so system will move towards the side where the ester has been formed because we are decreasing it. So the side where the ester is being formed is the backward side. So the acid concentration again decreases when it moves backward. So acid concentration again decreases because they're asking us about the acid. If we use more alcohol, if more alcohol Y is added, what will happen? If more alcohol is added, then system will move towards the side where there is less alcohol or where alcohol is not forming. So the side where the alcohol is not forming is again the backward side. So it will move backwards because in backwards alcohol is not forming. So the concentration of acid again decreases. The concentration of X again decreases. When a catalyst is added, the catalyst has no effect on the position of equilibrium. A catalyst increases the rate of the reaction. It increases the rate, but it has no effect on the equilibrium position. At the beginning of the reaction between ester and water, no carboxylic acid is present in the reaction mixture. Suggest how the pH of the reaction mixture changes from the start of the reaction until equilibrium is reached. Assume alcohols and esters are neutral. So at the start of the reaction, when there were no carboxylic acid, only ester and water was present in the starting, so we have to consider them as neutral. It means the pH in the starting is 7. It was 7, and when the equilibrium is reached and the carboxylic acid is formed, so the pH will be less than 7 because less than 7 pH is acidic. And as we know that the carboxylic acid is a weak acid, so its pH will be between 4 to 7. Identify the ion that causes the change in pH. So it is hydrogen ion H positive, which is responsible for the acidic behavior. Name an indicator which can be used to follow the change in pH. To check the strength of an acid or a base, to check the pH, we use universal indicator. Next question. Sulfur is a group 6 element. A sample of sulfur contains two isotopes S32 and S34. Now, we have to complete the table. These are two isotopes and the proton number is the same as their atomic number. If we see the periodic table, the sulfur atomic number is 16. So the number of protons will be 16 and 16 in both of them. As for the neutrons in sulfur 32, we will do 32 minus 16, so it's 16. And for sulfur 34, 34 minus 16, it comes out to be 18. Now, the next question, state why these isotopes have identical chemical properties. The chemical properties depends upon the number of electrons. So if the number of electrons in the isotopes are same, so it means their chemical properties are also the same. So why they have same chemical properties? Because they have same outer shell electrons or same electronic configuration. State the mass of 6.02 into 10 power 23 atoms of sulfur 34. Include units in your answer. So how much mass is present in this much atoms of sulfur 34? The mass will be 34 and the unit will be grams. Because in 1 mole of every substance, there are 6.02 into 10 power 23 atoms present in a 1 mole. So if we have 1 mole of sulfur 34, which contains this much atoms, so its mass will be 34 grams. State the name of the amount of substance which contains 6.02 into 10 power 23 atoms. The amount of a substance is 1 mole. The table shows the relative abundance of these isotopes of sulfur in the sample. Calculate the relative atomic mass of sulfur in this sample to 1 decimal place. To calculate the relative atomic mass, we will multiply the mass of each isotope with their percentage abundance. So here we have two isotopes, isotope number 1 plus isotope number 2. So isotope number 1 will do 32 multiplied by 95 because we'll multiply its mass with the abundance. So 32 multiplied by 95 plus 34 multiplied by 5, and we'll divide this whole with 100 because it's a percentage. After calculation, after multiplying and adding, it is 3210. We'll divide it by 100, and the answer comes out to be 32.1. This is the relative atomic mass of sulfur. Sulfur reacts with magnesium to form magnesium sulfate, an ionic compound. Complete the dot and cross diagram of the ions in magnesium sulfide. Give the charges on the ions. Now, as for the magnesium, which is present in group 2, so that means it loses 2 electrons and get 2 positive charge. And sulfur is present in group number 6, that means it has 6 electrons in the outermost shell, so it gains 2 more electrons to get 2 minus charge. So the charge on each ion will be 2 plus, magnesium will be 2 plus, and sulfide ion will be 2 minus. Now, if we draw their shells, then magnesium atomic number is 12. So its configuration will be 2, 8, 2, and after losing 2 electrons, it will become 2 and 8. So the first shell with 2 electrons is already made. We'll make the second shell with 8 electrons. And as for the sulfur, its atomic number is 16, which makes it 2, 8, and 6. So it has 6 electrons in the outer shell, and it gains 2 electrons from magnesium. So the first 2 shells are already made. We'll make the third shell with 6 electrons of sulfur. We'll make 6 electrons with dots. And then we have 2 electrons transferred from magnesium, which will be shown by cross. State why magnesium sulfide has a high melting point. Because they are having ions and they have ionic bonding between them. Ionic bonds are very, very strong. So ionic bonds are very strong. That's why the melting point is very high. They need very high energy to overcome these attractive forces. State why molten magnesium sulfide conducts electricity. Because the ions are free to move. In solid magnesium sulfate, the ions are not free to move, so that's why ionic compounds cannot conduct in the solid form. An acid containing sulfur reacts with sodium hydroxide to form salt and water, which is a neutralization reaction. The salt has the formula Na2SO3. Deduce the formula of this acid. Now, it is sodium sulfide. It is formed from SO3. So we have to write the formula of an acid. This SO3, the anion part of the salt comes from the acid. So the acid contains SO3 and all acids contain hydrogen. So it will be H2SO3. Deduce the formula of the anion in Na2SO3. So the anion will be SO3 2 negative. Na2SO3 is oxidized by acidified potassium manganate. State what this number refers to in the name potassium manganate. This refers to the oxidation number of magnesium, which is +7. Of manganate oxidation state of manganate ion, which is +7. State the color change when this happens. So as we know that potassium manganate is of purple color. It's of purple color, and when it gets oxidized, when it loses its electrons, it becomes colorless. Because the purple color of manganate ion is because of MnO4 negative. So in this ion, the manganese oxidation state is +7. And after getting oxidized, after it loses its electrons, it becomes Mn+2 from Mn+7. And Mn+2 ions are pale pink in color. So the purple color is because of Mn+7, which gets oxidized and form pale pink. So the purple color turns colorless. Next question. Glucose is involved in two processes. Glucose C6H12O6 is made in plants from carbon dioxide and water. Name this process. So this process is called photosynthesis. Write the symbol equation for this process. Symbol equation for the photosynthesis, very simple. The plants prepare their food by taking carbon dioxide, reacting it with water, and makes glucose C6H12O6, and they release oxygen gas. We'll balance this equation by writing 6 with the carbon dioxide, 6 with the water, and 6 with oxygen. State 2 essential conditions needed for this process to happen. Now, for this process to happen, we need direct energy from sunlight. And also this reaction happens due to in the presence of chlorophyll. So one of the condition is sunlight, and the second condition is chlorophyll. Glucose is converted to ethanol. Name this process. When the glucose is converted to ethanol, then the process is called fermentation. When the glucose is fermented under the influence of yeast, it forms ethanol and carbon dioxide. Name other product when glucose is converted. So this is carbon dioxide, which is a byproduct in the fermentation process. Ethanol is made by reacting ethene with steam. This is also another way. This is another way to prepare ethanol by reacting ethene with steam, which is the catalytic addition of steam to ethene. Now we have to write the conditions for it. For this reaction, the temperature and the units. The temperature which we use in this process is 300 degrees Celsius. The pressure is 6,000 kilopascal. And the catalyst which we use is any acid, specifically phosphoric acid. And its formula is H3PO4. Explain why this reaction is an addition reaction. Now, the feature of addition reaction, that why it is an addition reaction, is because there is no byproduct in addition reaction. In addition reaction, only the incoming substance get added into the reactant and nothing will be removed from the reactant. So if any substituent gets added, so It means the addition reaction without anything getting eliminated. So there is no byproduct. Complete the dot and cross diagram for the molecule of ethanol. So if we complete it, carbon atomic number is 6. So it means its electronic configuration will be 2 and 4. It has 4 electrons in the outer shell. So as for the carbon, we can make 1, 2, 3, and 4 electrons for carbon. For the other carbon also, it will be 1, 2, 3, and 4. For hydrogen, hydrogen has only 1 electron in the outer shell. So it will share 1 electron. Each hydrogen will share 1. Here you go. And with oxygen also. And if we see the oxygen has total 8 electrons, which makes its configuration 2 and 6. If it has 6 electrons, so it needs 2 more electrons, so it will share also 2 electrons. So each oxygen will share 2 electrons. Here we have only 1 oxygen and it is sharing 1 electron with carbon and 1 electron with hydrogen. Rest of the 4 electrons will be outside. They are the lone pair of electrons. So here you go. Our paper 4, variant 2 is complete.